Okay, I've lost my cameraman, so please bear with me. The project is complete. I've wired in the 220 volt sub panel. I've wired in a 220 volt outlet for the compressor right here, and I've attached, here's the plug right here for the 220 volt motor on this air compressor, which is the reason for this whole project. It's showing you how to do that. Now, as you can see, here's the main panel, and on the main panel there I've jockeyed all my breakers around now. So I've moved and shifted as need be. And what you can legally do, you can see this gray wire right here. You can see the red of the wire nuts in the back. That fed another circuit that I don't need anymore. It was a shed that I'd never supplied power to. And I've coiled that up inside this panel and capped it off. Okay, and that's legal. I've also, over here, you'll see another circuit. This was for an intercom that was never used in the house. Never will be with cell phones these days. That was also caught up. I needed two circuits open because I needed two spaces for 220 volt supply. So things have moved around. Here's my 220 volt 40 amp supply breaker. Originally it was going to be a 20 amp, but I spoke with the county, amended my permit, and allowed me up to 40 amps with this 8 gauge feeder right here. That's the max I could do with it. And as you'll notice, here it is. Here's the two hots coming out. 220 has two hots, no neutrals. Two hots, no neutrals. So you won't find a white wire going to a circuit on a 220 on this 220 volt. So again, your two hots coming in from the power company right here, feeding each bus bar, and then I'm picking off with 220 volts. I'm picking off each side, feeding out, down. Here's my neutral for the power that's feeding the sub panel. There's a neutral going up and tying in with the rest of the neutrals over there, and you can see in the back here the shiny copper right here. So you can see me moving. That is the ground for the sub panel. Okay, so power comes out. It's coming down through here, through. Let's take a look on the other side. Here it is coming back. There's your power coming in. The black one on the bottom comes in and feeds up into the sub panel. Okay, and you can see there's my permit. Everything is final inspection. Everything is passed. Just to lend some credibility to this video. As you can see, here's the two different bus bars. Here's power coming in right here. This is the power coming in. This one right here, black coming in. Hot. Red, white are both hot coming in. There are no neutrals, remember. For red and black are both hot. White is neutral. Neutrals going up, over, tying in over here on the neutral bus. There's two neutral buses in this panel that are tied together with this bar. Hot, hot, coming in, feeding each bus. One side, other side, and you can see how they alternate, like I mentioned before. There's one side, there's the other side. And with a 220 volt breaker, it bridges two different sides. That's how you get 120, 120, 240. Coming back out, these are both hot lines now. Once again, on this 220 volt circuit, there are no neutrals coming out. So that's hot. This white is hot, feeding out, down. Here's the ground for the outlet that I wired in right there. There's your ground coming up. Goes out, goes down, goes through, and let's swing around again. And it feeds that outlet right there. Now notice the unique look of the outlet. There's a distinctive look. It's hard to see, but there's a standard outlet right there. Notice the look on that one. Let's find a standard outlet in the garage. I can show you the difference. Here's one right there. That's what you're used to seeing. Two vertical, hot and neutral, and a ground at the bottom. With a 220 volt, you're not going to see that. Okay? You're going to see this design, this difference. Which the idea behind this type of pattern is to make it impossible to accidentally plug in a 120 volt load into a 240 volt outlet. So that's why it looks this way. Now coming in on this side, coming in through the wire down here, through the feeder, goes up. Remember, it has to be stapled prevent the wire from being pulled out of the outlet. So that's a requirement for the inspection. It's got to be stapled in place, attached in some way, fixed in place. And then black comes in on one side, the white or hot lead resistance comes on the other side, and my ground is hooked up as you normally would. And the plug there, as you can see, is just the mirror image of the outlet on the other side. Okay? And that's how you do it. That's how you wire a sub panel into a main panel. Just remembering that on the sub panel, depending on where you put it, will determine on whether you can, they call bridge the ground and grounding and ground leads. In other words, here over here is neutral, ground, neutral, ground. Neutrals are bonded. In the sub panel, depending on where it is, in some instances you can bond these two together, and sometimes you can't. That'll be determined by your building code. In this instance, I cannot do that. They have to be separated. Okay? The main panel is the only place where ground and neutral will come together. The only place. Otherwise, it's kept separate. And you don't want that to happen over here in the sub panel. You don't want you want a ground to be able to actually go to earth. That's it. That's all there is to it. It's really not that hard. If you're experiencing this, you can probably do it in a couple hours, 3 hours maybe, tops. If you're inexperienced in this, it may take you an afternoon or a day. Don't rush. If you get tired, come away and come back. Remember, while you're wiring, keep these breakers open the whole time and go from load to source. So get all your wiring out here done. Get your sub panel mounted. Get your wires run into the sub panel. You can run it either way, from there over there or here at the back, whichever is easiest for you. Get them all in. You can get them all hooked up. Remember, because this isn't connected to hot yet, so this is all dead, so it's safe. Hook all your wires up. Hook everything together. Get your breaker in, get your wires all hooked up. Then on the other side, what you're going to do is, if you're careful, you can do this live. Now I wired this live. It was easier just to keep the main breaker up here on, and I was only working in the bottom, and I was just careful. So as I pulled breakers in and out, I was just careful. As long as you open the breaker, the hot side is dead. So as long as you open, like instance, this breaker, as long as I open this breaker right here, its corresponding hot side is going to be dead, right? Just be careful. And it's best if you're tired. No, it's not. Doesn't hurt to have somebody out here sitting with you for conversation, and also to call or help you out if there's a problem. And not necessarily an injury problem, but just you reach something. It's easy to start getting tired and start getting your head too close to this, or start reaching out for a tool and really not paying attention to what you're doing. But there you are. It's easy. It's power. 2 hots coming out. 2 hots going in the other side. Neutral. Ground back there. And like I say, with the sub panel wired up, you bring everything back in here and you make your hot connections last, making sure this breaker stays open until you're done. And then be very careful. Check for grounds. Do one idiot check, just make sure it all looks right. Check for continuity and check for grounds, and then slowly power it up, powering from here, shutting this breaker first, making sure there's no issues, and then coming over here and making sure everything looks good, and then shutting this breaker, which is the power supply. And then check, when you shut your first breaker, check to make sure from here to ground will be 120, from here to ground will be 120, from here to here will be 240 volts, okay, or thereabouts. Don't worry if the multimeter jumps around some. That's normal for especially digital multimeters. And remember, once you shut it, check from here to here should be 220 volts. It should be 240 volts, 220, 240 volts. And then between here and ground and here and ground, zoom in a little more so you can see what I'm talking about, between the hot and ground, and between this hot and ground over here will be 120 volts. Okay? Make sure everything looks right. Look around, look at the wires, look at the way they come in. Make sure you don't have anything crossed. Make sure that there are no nicks in the wires, in the insulation. You have gentle bends. The way I bring it in here is I like doing it this way because I have a slow easy curve. It's easier to work with the wire. This 8-gauge wire is a bear to start bending by hand in some instances, so I didn't want it to come in and have to do a tight turn up here to come right back to this ground. So I just made it bigger loops. It was easy to work with. Okay, make sure all your screws are nice and tight. Some instances, the manufacturer will give you torque specs for these particular screws. They'll be in the cover. All right, and try to keep it neat as possible. Don't have wires crisscrossing, bent up against one another, knotted, whatnot. Try to make it as pretty as you can, because that will make it a lot easier next time you have to wire something up. You can be able to follow the flow and you're not having to push and bend wires out of the place, all over the place, out of the way. Okay, and that's it. Good luck.